Okay, so what we have here is a difference of two squares binomial. We can make this a little easier if we factor greatest common factor out first before we use the factoring formula. Greatest common factor of these two terms is 4. So if I factor it out of the first term, I would have 16x to the 4th power minus, and if I factor it out of the last term, that would be minus 1. Okay, so I'm going to factor this part using a difference of two squares factoring formula, and that formula looks something like this. A squared minus b squared is a plus b times a minus b. Okay, so if you look at the first term of this binomial, 16x to the 4th, that's perfect square of 4x squared. And then the last term, 1, that's perfect square of itself. Okay, and the only reason I wrote it that way is so that you could just easily identify what a and b are in the formula. Okay, so we have a plus b, that would be 4x squared minus plus 1 times 4x squared minus 1. And that's using the factoring formula. We're almost done here, except that this binomial in parentheses here, this is also a difference of two squares, and we're going to have to use the factoring formula in it also. Uh, 4x squared, that's a perfect square of 2x. And 1, again, is a perfect square of itself. And according to that factoring formula, 1's a sum and 1's a difference. And this is the complete factorization. Now, you might be wondering about this binomial that's in parentheses, 4x squared plus 1. That's actually a sum of two squares, but there is no factoring formula for a sum of two squares. So we're done here. This is the complete factorization.